Hello, everybody. We would like to welcome African Energy to this webinar. Please welcome our CTO, Eric Wang, to begin the webinar on the FAQ of lithium energy storage. Eric, go ahead.
All right. Good morning, everybody. So my name is Eric. I'm the lead engineer of Fortress Power. Just a little bit about myself. So I've been about 15 years working experience in the automotive and energy sector. So has been 4 years in the energy storage business. Previous life always in the automotive manufacturer and also in wind energy business. Today we're gonna cover a few major topics. So the major things we want to cover is how to understand our product. So we'll talk about the Fortress Power. We'll talk about the lithium battery, why we choose lithium, and then we'll spend a good amount of time in the system design and installation guide, and also the important things that when you install system, we're going to talk about the parameter settings in your system. So we're going to talk about ourselves first, Fortress Power. We'll talk about our product line and talk about where we're located at, and then about our histories as well. So we have been in the solar business for 15 years, so we're not new in this business. And in the past 4 years, we step into the energy storage because we see that's the future. So we bring the automotive experience into the energy storage business. So that's whatever we use and we pick, we design, it's all according to the automotive standard. So our headquarters is in the US, in the Greater Philadelphia area, Southampton, PA. We have 30,000 square feet facility for R&D, sales, logistics. So all the test design is complete here. And we do have a logistics center in California and Florida to cover the West Coast and Latin and South America market. In the past four years, we've been installed 50 megawatt worldwide. So have pretty good tracking record, have a good reputation in the market. We also become the primary battery supplier for the local railway system. Usually railway has a very high safety standard and based on a special guideline, a protocol we have to follow. So we already engineered the product to support this business. So if you have a similar application, you can contact us. We can give you a customized solution too. In our catalog, so as I mentioned, we do customize solution, but majority of our selling product in the market is catalog product. We have 3 major product in the catalog. They differentiate from the capacity, input, and output powers. From the left to the right, you see that's the biggest capacity one we have is 18.5 kilowatt hours. And then we have a 10 kilowatt hours and 5 kilowatt hours. So it also differentiated from the input and output power. So the eVolt, so take the most of power from the system and give out the most power to the system too. It's a high charge and discharge rate. So the 10 kilowatt is in the middle, and then the 5 kilowatt hours is the smallest one for some small applications. We do have some new product I want to talk about here quickly. Jimmy, if you can go next slide. So it's our new eFlex. So this product is designed for more versatile applications, and the product is 5 kilowatt hours, 5.4 kilowatt hours per pack, and it's highly stackable. So based on the customer requirement, we can stack up to 200 kilowatt hours in one system. We also integrate a smart embedded computer and to be able to communicate with multiple different inverters, and then the computer system do the data logging for the major event, what's happening in the battery pack for the quality tracking purpose. And it also has a Wi-Fi module built in, so we can choose to monitor that on the iPhone app or Android app, or we can also choose to monitor that on the cloud service if you prefer to do it. In terms of the installation, so you can sit on the ground and put it on the wall. We also provide a nice enclosure solution, so you can put the 4 battery in one enclosure. It's a furniture finish style, so if you put it in the garage or anywhere, it looks pretty. It's highly flexible, as I mentioned. It's a high IP rating, very smart system. So if you have a marine application and those high corrosion areas, so that's the perfect solution for that too. So we designed the system to be more flexible, adapt to the different applications. This product is available in later June, and then early July, you should be able to see this in the market. So we talk about quickly the specification. As I mentioned, so the product is differentiated from the capacity and input-output powers. So the eVolt, eFlex are all contactor based and with the embedded smart computer as a BMS. And then the LLP10 and LLP5, they both has a MOSFET solution, so as BMS. So the difference is on the eFlex and the eVolt. So they both are highly stackable. So you can stack up to, as I mentioned, eFlex you can do 200 kilowatt hours, and then eVolt you can do stack it up to 15 units. And then LP5 and 10 usually only allow that you stack up 2 in the same system. In terms of input and output powers, the eFlex and the eVolt has the best tolerance if you have a special application and the surge powers or inrush current. And the LP5 and 10, they will just do the work and compatible with the majority of the inverter in the market. Work on all of the product, we have the circuit breaker or fuse in the system. So the eVolt, LP5 and 10, that's all with the breaker system. And it will help you as a last resort if something happened, the breaker can trip. So eFlex is internal fused, so you don't have to worry about it. If the worst thing happened, the fuse is going to break up, so the system got protected. Let's go. This is a quick overview of the. Jimmy, can I go back to 2 slides? Yeah, this is a quick overview as we just mentioned. So this is a very nice cheat sheet when you size the system. We'll keep this in mind. We'll talk about how to use those parameters when we design the whole system. Next slide, please. As I mentioned, so the BMS overall, all of the BMS in from Fortress Power, so we design carefully. We put a good amount of safety factor in it, and is based on 2 types of technology. So one is MOSFET integrated circuit board. The other is the contactor plus embedded computer system. And then on the smaller application, LP5 and 10 is perfect, and we use a cylinder reticle cell. And in the a larger application, so the eVolt and eFlex is just the best solution for that. So we use the prismatic battery cell. Both are lithium phosphate, it's just in a different shape. Next slide, please. So when I talk about quickly the live monitoring system on the eVolt, so we do have the LED RCB display on the eVolt, so you can look at it and give you very good visual feeling. So what the battery is doing, it's charging, discharging, what's voltage, and then what is the state of charge, and then what is the power coming in and out. So we also have a few icon on side of the screen, so tell you if the battery if the battery BMS working in what mode. So for example, it might be protected because you overcharge the batteries. So high voltage, low voltage cut out too, and then also temperature sensors and also short circuit, open circuit. It tells you what's happening in the system. When you do the installation and when you do the troubleshooting, so this gives you a little bit better feeling. You can diagnostic the problem immediately. But sometimes the lights on doesn't mean it doesn't work. It just means the battery stop taking power or stop giving out powers from the system. Most of the time is because of the inverter parameter setting need to be tweaked a little bit according to our instruction. We'll talk about that later in the last section. Next slide, please. So battery, why lithium? We have been living on the battery for 100 years, from very old one to the lead acid to the advanced lead acid. So why lithium? We're gonna do a little bit comparison here. So lithium battery in general is just better in every single way than the traditional lead acid battery or AGM or any other batteries at this moment. I can't see in the future, maybe there's a dry cell or the other thing is coming up, but at this moment for energy storage, this is the best solution you can find in the market because it's a long lifespan, low energy cost in the long term, and then the efficiency is super high, and it's compact and lightweight. So on the picture on the left, you see we have around about this 13 eV. So this is the room they used to put the lead acid in. I tell you, it occupied the whole room. So we kick the lead acid out, only use 1/3 of the original space they have. A good thing on this lithium is zero maintenance, no ventilation needed. So a lot of lead acid, especially flooded lead acids, always need the ventilation system because the emission from the chemical reaction. And then in terms of depth of discharge, so the lithium can do 100%, lead acid 50% maximum. If you discharge under 50 or under 30, it's guaranteed you have a good chance to break the batteries permanently. The lithium battery support the what we call in the traditional booster charger for the lead acid. So this support quick charge and discharge. And then when we do the power throughout, right, giving all the powers, it give a consistent power output in compared to the other batteries. So on the left, you see the chart. The green line is the power output from beginning of discharge to the end of discharge. It's always consistent, roundabout at 100%. And the other battery, because the voltage drop is so much, right? So the current keep increasing, so their output power just deteriorate along their discharge processes. Next slide, please. We're gonna just quickly compare what I just talked about. I'll give you some quantified numbers. Round trip, the lithium battery run about 98, 99%, and all the other batteries, the max one is AGM, they call it advanced lead acid, so it's 88%. And then life cycle at 80% of DOD. Beside the nickel iron battery, which is super expensive because nickel is literally the money, and all the others just way off. So the lithium battery usually, especially lithium phosphate, the chemistry we are using is 6,000 cycles. And off-grid years in theory, so the lithium phosphate can last for 16.4 years because 6,000 is calculated one cycle per day. All the others just it depends how you use it. It doesn't last as long as you thought. And the overall throughout from the one batteries, the lithium phosphate just give a 47 megawatt in the life cycles. And then the other lead acid is just much lesser. And as I mentioned, the nickel is better, but still their initial cost is super high. Then we come to the cost portion. You can look at the cost differences, right? Initial cost on the lithium phosphate is slightly high, is higher than the traditional lead acid. But if you calculate the cost per kilowatt hours, is lower, so it's only 14 cents in your whole life cycles. Safety side, we're very safe. Lithium phosphate, we'll talk about compared to the other lithium batteries. And the maintenance, we don't need any maintenance. All the other battery more or less need a little bit of maintenance. The advanced lead acid, you don't need a maintenance, but they don't give you a good amount of the other performance as I mentioned. Let's go to the next slide. We look at specifically the lithium battery, the lithium chemistry we're using. So in the market, there are a lot of different lithium chemistry. So I cannot count with my fingers, but most commercialized are three. One is the LiPo, the other is we call it NMC. That's usually Tesla. Those car manufacturer, especially for the family car, they prefer to use that. And then the other one is lithium phosphate. So lithium phosphate battery is usually used for the big commercial car and also for the energy storage product. It had a significant advantage if you use lithium phosphate as the energy storage product. In the energy storage product, it has a very high efficiency. Life cycle is much longer than the others. And then the energy the output from the total life cycle is much longer, and homeowners' cost is longer through the long run, and it's very safe compared to the lithium ion or LiPo batteries. Maintenance all free. The only disadvantage of the lithium phosphate is the energy density. So it's around about 10 to 15% less than the lithium ion or LiPo. So that's why a lot of most of the family car, small car manufacturer try to use the NMC, which is a lithium ion or LiPo, because they want to achieve the density of the energy. They don't want to carry too much weight in the car, so they can extend their mileage. But it doesn't matter for the energy storage. So we have space in the garage, we have space in the basement, we have space outside. So we want to take safety as the first priority, and the life cycle is a priority. So lithium phosphate is a perfect solution for the energy storage products. That's why we choose lithium phosphate. I give you a quick slide of penetration test. Jimmy, if you can go next slide. So this is the penetration test. So standard testing when we do our R&D job. So on the left is the lithium phosphate cell, and on the right is NMC cell. So NMC is just I use a short name, lithium ion. It should be the lithium nickel magnesium cobalt oxide. That's too long. We call it NMC. So when we do the penetration test on the both battery, then you can see on the lithium phosphate side, you only see slightly smoke come out. That's because of the structure and then also the temperature to catch fire on the phosphate is lower than the cobalt. So on the NMC, as long as you put external force on the battery cell, it starts sparking. So that's why you see a lot of news like LG Chem or car manufacturers, so they more or less catch fire from one place to another. That's because of these issues. So lithium phosphate, you have a less chance to get a serious fire problem, which is seriously concern when we do the energy storage business, because usually stay in somebody's home or next to the home. So we don't want the bad thing happen, especially we have to call the firehouse. Okay, there's a lot of study on the YouTube, a lot of study, academic study on the internet. So you can look at it if you're interested in it. If you want more information, email us. We're gonna give you some examples and talk about it with you. Then we talk about the major topic today. So we want to spend the majority of the time here to see to understand how to design the system, especially when you design or you install the system before with lead acid. So the first thing, okay, compatibility with the current inverter in the market. So we produce 48-volt system. We produce 48-volt energy storage battery, and it's compatible with most of the inverter, 48-volt inverter storage product. For example, Schneider Outback, SMA, Magnum, Zork, Victron, Morningstar, Midnight Solar. I don't know in Africa what is a major brand there, but if you have a new inverter come up, send us email. We'll help you to look at the specification. Then we'll help you to size up the system. We'll help you to do the parameter setting, and we'll check if that's compatible with our battery or not. Usually the rule is most of the configurable charge controller of a 48-volt system is compatible with our battery. So it's not a big concern. If you see the inverter take a 48-volt batteries, most likely that will work. Okay, next slide, please. Example, so we did a Schneider system. They're worldwide company, the big giant, so they've been in the solar business for a long time, and they've been supplied this XW serial product in the US and also worldwide. They have two versions, one for the US version, which is the split phase, and they have the standard version for the 240-volt 50 hertz system too. So they have a full product line. So we did a lot of system with them together. They support the single phase, they support split phase, and you also can configure to 3-phase with their inverters. And then the system allowed you to do DC couple, right? If you have a new system, if you have a retrofit system, AC couple, it works too. And then it control your generator if you have a generator sit on side of your house. then it controls. So there is a certain parameter set up. It's kind of a center to control every element in your energy system. So you can configure the system to work with a multiple model, right? Time of use, you want to do off-grid, you want to do load shifting, you want to use only for backup, or you want to sell your electric back to the grid. So that this machine has been designed to accommodate most of the requirement in the market. In the hotter temperature, it works better than the others. We just take the examples. We didn't take any advertisement things. It's just we've been working with this inverter for a long time. We have more experience with it. So all the other inverter company had a similar function. You just need to look at the spec of it. So you see the first slide, the inverter we have. You will find all the resources of integration guideline with those inverters on our website at www.fortresspower.com. Okay, next slide. Design, you need a tool. So when we design things, energy storage is a little bit new for the customer. So we make a homemade tool. You can use. It only takes 4 steps to configure your whole system, and it gave you where to build in our product and also build in the compatible inverter product. So once you finish your basic data input, and then you should be able to choose what inverter you want, and the system will tell you how to work. So you go with the first step. So select a critical load panel, and then you calculate your total usage, and then you look at the battery bank size, and then you also want to look at the weather, estimate the daily available power. So we'll go through in the next couple slides. We'll just go through these topics. But I want to make this. We want to make this things really easy for every installer. So we said there's a quick dirty rule when you size up your system. Quick dirty rule is if you have an inverter decided. So for example, I decided to use a 5 kW inverter, continuous power. The quick dirty rule is you just take that rated power on their label times 2 and add H at the end, becomes 10 kilowatt hours. That's the battery size, bank size you usually need. I can tell you in the 70% of a chance you hit the target, so you won't size up a system too wrong. So this is a quick dirty rule. So usually we want to size up the battery bank 2 times the rated powers on the inverter. But that's not what we want to do. So we're professional, so we want to go with a full power rule. That's the second one I tell you. Remember 4 times power, ask your SIMs 4 times powers. Then most likely you have a 95% of chance to size your system correctly. 5% is special situation. You have to email us, we'll help you. So we look at the 4 power is a continuous power, peak power, total needed power, and maybe you want to look at the charge source power. So it's not very accurate. I said a total needed power because I want the people easy to remember. So it's actually total energy needed. You just remember as power, just how many kilowatt hours you need. So we'll stick with a full power rule in the next section, which is go one by one to give you a live example how the system work. Next slide, please. Example of our sizing tool. Easy to use. It's just like go through your book list and then put your number in. The system will calculate it for you. So in the first section, category, items, quantity. So you see that's all the things that you want to put on your critical panel. I want to put a freezer, refrigerator, LED light, some pumps. Then you put in the quantity. You have 2 freezer, you put 2. You have 1 freezer, put 1. So how many lights you have? And then you want to look at the starting watt, running watt. Starting watt usually is like the well pump, all those things has a little bit inrush current, so you need a little high power to start it up. Once start up and running, so you just run smoothly with lower power consumption. And then you want to also understand, okay, how many days, how many hours I use them per day. Then the system calculate, okay, what is the kilowatt hours you need a day. So when we run the system, after fill out all the critical panel items, then we'll come to the end. You can it give you a summary total calculation of how many power you need. For example, in this case, 18 kilowatts. And what is a continuous power running power? It's 5 kilowatt more or less. And with the starting watt, so there's a 7.3 kilowatt. So those three factors just I mentioned. So those three powers. So it's the continuous power, your peak power, and also the total power needed, total energy needed. And then you can choose the inverter type. For example, we want to go with Schneider XW 6848, and then quantity we want to go with 1, and then the system will calculate, will give you green. So the green part that tells you is how much power left on this inverter. If you can put more item on it. If it's turned to red, that means you already go over this this inverter capacity. You need to size up your inverter a little bit more. Maybe you need a 2 inverter. So for example, this one on the surge power side, it still have a 4.6 kilowatt left, and then on the running power side, you have 1.6 kilowatt left. Just example, so any authorized installer can get this tool from us. It's a program in the Excel sheet, super easy to use. Again, any question, contact us, we'll support you. Actually, we do a good amount of sizing job for our customer. So the customer always want us to look at, take another look, make sure the system is correct, because solar system is expensive, so we don't want to make mistake at the first place already. Okay, next slide.
Eric, just really quick, Steve Green just said that we use Schneider, Outback, Magnum, Growatt, Morningstar, Focus, Emon inverters, and charge controllers.
Can I say it again? So I didn't hear the last part.
He said that we use Schneider, Outback, Magnum, Growatt, Morningstar, Focus, Emon inverters, and charge controllers.
I didn't get you. So he just
said that these are the inverters that they use.
Okay, that's perfect. Okay. Yep. Well, that's cool. So we don't have a compatibility issues. Let's take an exercise. Don't worry about it. It's not school, so we just want to run through the exercise with one live examples. So we said, all right, we want to see how many IFP10 we need in the system. So inverter, we say we use XW Pro version, and then it has a 6.8 kilowatt rated power. Surge power can do 12 kilowatt for 60 seconds, and we also calculated the current for you. So 136 amps in the normal case. Surge power case is 240 amps. And then we also have 2 charge controllers where Jeremy is pointing at, MPPT 6150. And then the battery specification is just a breaker is 150 amps DC. Max discharge rate, we recommend 100 amps, which is 0.5C. Surge power is around about 180, and then that's for a few seconds. And then max charge rate is 80 amps. So come to the battery, you really need to look at the amps. So that's the bottom line, because that's determined what is the conductor we use, circuit breaker can take, and whatever. So let's solve this problem. Give me next slide. Again, so I promise you, I mention the powers all the time. So continuous power, we want to calculate, and the surge power, we want to calculate, total power calculate, and the charger power, we want to look at too. So that's 4 power rule. I list out all the equation here. Don't worry about it. It looks complicated, but it's super easy. So we're going to look at the first tool first. Firstly, let's look at the continuous power and the surge power. Jimmy, can you go to the next slide? So in this real case, we want a continuous power that said we want that the battery bank continuous power are over the inverter continuous power rating. So what's happened is we don't want the inverter put too much power from the battery bank, and which is over the capability of the battery. Lithium is different with lead acid, but no matter which battery, you need to treat them fairly. If you put too much, they die early. So especially on the lithium, it has a certain protection. It has a BMS system, so it's going to cut you off right in the middle of the night or when you use high powers. So for this one, we say IOP, if we use 2 10 kilowatt hour battery, then that's give you 200 amps continuous output, which the Schneider in the usual system only use 136 maximum as continuous power. And then when we to look at the second one, which was surge power, which we also can call it the peak power, then we can do 300 with LP10. And you see on the Schneider, so there's surge power on 12 kW, right? That's 240 amps. So 300 are bigger than the 240. So we solved the problem. In this scenario, for continuous power and surge power, we needed 2 LP10 to support the whole system. That's based on the 10 kilowatt hour battery bank. If you use eVolt, as I mentioned, that's 18.5 kilowatt hour capacity battery bank. So one battery will support the whole system because output power is high and the inrush current tolerance is high, and then the charge current is high too. So that one, you can choose one battery, just go with one system, just side notes. But we'll take example as a 10 kilowatt hour battery bank. Let's go to next slide. We look at some quick cheat sheet. So most of the inverter has the circuit breaker. There are either delay version or instantaneous trip version. So it doesn't matter. Don't worry about it. Don't struggle for what the version is it. So we try to make it simple. So every battery we have beside the E-Flex, so we all have a circuit breaker. Smaller one has 105, and then 10 kilowatt has 150, and the eVolt has 250. You just need to think about match the circuit breaker with the circuit breaker on the inverter. So that's usually how we design the system. It give you a piece of give you a good feeling to size the system correctly in the easy way. So if you want to go with 110 kilowatt hours, it only has 150 amps circuit breaker, and you want to match to the Schneider XW, which is the 250 amps circuit breaker. It doesn't match. If you put too much current, if the inverter put too much current, it's going to trip the DC breaker on the battery first. The system is going to shut down. Schneider doesn't work without DC power input. That's how the system works. And then the same as Outback, the same as multiple the other inverter company as well. So when we design the system, we want to look at it. At least my circuit breaker on the DC battery side are over whatever we have on the DC breaker side from the inverter. So in this case, 2 times 150 amps delay version of circuit breaker will be perfect fit for one Schneider inverter, which is the 250 amps. Again, with our eVolt product, that's already have 250 amps circuit breaker. It's a straightforward, so just match with obviously all of the 48 volt system, 48 volt storage inverter in the market. So the biggest the DC circuit breaker I've seen on one inverter is usually 250 amps. Okay, let's go next slide. Then we can look at the total energy, how we size the capacity of the battery bank. That's another angle to look at it. So we remember 4 angles. So the first 2 angles, continuous power and the surge power, where we look at it. Now we want to look at the third angle is total energy needed, total power. So look at the critical panel, as I show you in the first slide, the energy sizing tool, our Fortress Power sizing tool. Then you add up everything, it gives you the total energy, total power you need continuously. With the hours, then you becomes the total energy you need for a day. We want to size the battery bank just 90% of a depth discharge. That's why your total energy divided the total available energy in the battery bank times 100% should be less than 90%. Don't try to discharge the battery 100%. It's gonna kill the battery quicker, short your life cycles. It doesn't pay off, right? So if you discharge the battery 100% every time, it probably give you around about 2,000 cycles, battery is gone. If you charge to 90% or 80%, it's going to give you 3,000 cycle and 6,000 cycle, as I mentioned here. So try to size your system a little bit bigger, 10% or 20% bigger than what you use in the typical daily consumption. The customer said, I can't do it. Someday I just need more energy. If you do it once, or if customer do it once or twice in a month, it won't impact too much on the life cycles. We can't let customer use that every day, because that's definitely not good for batteries. Not only for lithium battery, for every batteries. Basically, we want to use the battery in the best situation and keep the longevity of the product. Let's go to the next slide. And we look at the charger source power with the PV system. We'll talk about the more complicated system later in the next slide, but this slide we want to talk about the charger source. So usually you have a charger. If it's separate MPPT or integrated MPPT, I mean, you have to look at what the inverter you're choosing. So I take a typical example here. We say if I have a 2 lithium battery, then the inverter charger from the grid can do 120 amps. And then 1 MPPT can do 60 amps from the Schneider system. And then overall it's 180 amps. So we recommend 80 amp charge rate for each battery. So 2 will be 160 amps. So 180 is over 160, not recommended. Let's go to another route. So what do you do? Still first slide. Yeah, what do we do? Most of the inverter and the charge controller are highly configurable. So you can configure the charge rate to the battery spec. So you can deread the charge rate from the inverter side, also from the charge controller MPPT side. So just try to tweak it under 160. You'll be safe. For in this case, I tweak everything to 60 amps. So if both of them charge the battery at the same time, maximum will give them 120 amps. So that will be pretty safe for the charger situation for when you charge the batteries. Let's come to the next slide. There are something out of ordinary. So if customer has a wind turbine, has a generator, has a PV system, and has something else, they all want to charge the batteries. So it's not a big concern if you regulate everything with the one inverter. For example, your PV go with the inverter, generator also go with the inverter. Most of the inverters support the complicated configuration when to use what. So it's not a big concern for the battery. But if you have a wind turbine, so you go with a separate charge controller. If you have something else, the third source like a DC generator, you want to charge the batteries. That's something you want to pay attention to. Either you need to think about the overall system and deread the overall system charge rate, or we have to be creative, do some manual work when we really go into the dark to charge the batteries. In this situation, I highly recommend you send your inquiry in, and we're going to talk about it. We'll help you to size the system, we'll help you to design the system. But there's a 3 takeaway, always remember. So generator, not a major concern. PV, not a major concern, because that thing is controlled by the inverter. Be careful with wind charge controller. Be careful with the DC, diesel or propane charge generator charge source. So anything out of ordinary, we want to give another thought, another look. Call us or email us, we'll help you on this. All right, let's go to next slide.
I have one question here.
Yes.
Which type of breakers are the batteries using? Also, do you have published time current curve for the breaker in order to check the inrush current?
Yes, we do have that. So, and the DC breaker is 125 amps, 250 amps, and 150 amps, 3 types based on the different product. And all of the inverter are delay version. It's not instantaneous trip. When we design the system, we fully test it. All of them deal with short-term inrush current, at least for 20 milliseconds. So we test a lot of systems. Usually this breaker trip the last. So don't worry about the inrush current, short-time impact on the inrush current. If you have a a big motor like 50 horsepower, 20 horsepower, those things need a special design. Then we need to think about let you choose a motor starter in between, so that will make the system a little bit more smooth. Again, any questions, just email us. We can set up a conference and talk about it. I don't know if that's answered the question. If not, then you can keep typing. So Jeremy is gonna keep pushing question to me. Last slide, special technical notes on the AC system, AC couple system. AC couple system is very popular because a lot of customer has PV system already, but they don't have a storage system. They want to go for the storage system. Most of the DC couple inverters support also AC couple solution as well. Again, here we take example from the Schneider system. The technical notes I gave to everybody is I want the people to be aware of this. So I know in the market, the PV inverter and also the storage inverter, so they have a certain mechanism to regulate the PV production. We call it the frequency shifting. So it triggers the frequency shift from the storage inverter, try to stop the PV inverter PV production if there's too much power come at the storage inverter. That's very good technology, but Jeremy, you need to go back to the last slide.
It's having a mind of its own. It's not even letting me, hold on a second. Let me know which.
The slide we see AC couple, no, AC couple.
Am I going the wrong way? I don't know.
You're going the wrong way. Yeah.
This one, okay.
Yeah, okay. Well, sorry, my computer has a little bit of technical problem today, so I have to let Jeremy navigate for me. So where I stop? So okay, so it's very good technology, but if you let the system work always in this way, you will get the really bad customer experience. So flashing light, because every time switching some on and off, is always interrupt in a very short time of your power supply in the house. We try to avoid it. The design note on this, we always want the customer, or we always design the energy storage part bigger than the PV side. For example, if a PV inverter is 5K, I will definitely design the energy storage inverter 5K or above. I leave 10% on it. I try to use 6K because it just can take more powers, and then it's more tolerable in the system, becomes a buffer. The energy storage part becomes buffer, especially with the lithium battery. It's perfect power buffer because you take more energy and then quickly, and then also release more energy quickly. So if you have in a very good day, the energy is just gonna dump in, and then if you don't have enough appliance use the energy all go into the battery bank. It helps you to buffer your energy and later to use it. So remember one thing. So more specifically, at least we want to see the PV inverters rated power are less than the energy storage inverter rated power. And then the PV array, right? PV array, we want to see that is smaller than the battery bank size. The reason I say it is a lot of PV inverter actually allowed you to hook up a little bit more than what they rated. If they said that only take 5K, you can put 6K because they consider what about the shaving, what about bad weather, what about the productivity, and so on. So that's usually you want to look at it. But we want to consider the worst scenario. If you have a 5 kW inverter, 5.5 kW PV array, and then you want to match those things with your energy storage. So 6.6 kilowatt, maybe the PV array you want match with the battery bank. Let battery bank are bigger than PV array, and let the energy storage inverter rated power bigger than the PV inverter rated power. That's technical notes. When we design, we really want to pay attention to it. I know the inverter company will tell you, no problem, frequency shifting, but in the real life, you want to pay attention to this. Okay, next slide. Okay, then we look at the total energy consumption estimate. So, Jimmy, can you just click on this slide so we'll get a two picture out. Yep. A quick recap. We need to look at whatever we put on critical load. Usually a well pump, your maybe water heater, your phone charger, all those something you use, you want to use when the power is off. And those are we call the critical panel. For example, here we calculate 18 kilowatt hours per day. That's where we start sizing our battery bank. We say, okay, at least we need that much energy. Jimmy, next slide. If what another factor is, you really want to look at the PV production. I don't know in Africa or the other place, but in US we have a website. You can go on it to look at your area, what the typical radiation from the sun is. It gives you the total PV production per day in the best scenario, worst scenario. You just want to size these things correctly so you can supply the appliances in your house. At the same time, you use part of the energy to charge your batteries. And then there's multiple different ways you can do the configuration. If you want to charge more from a grid, if you want to charge more from the PV system, it's all up to you. But this is an information sheet you can look. So in the US, we go on the website. I think Africa, you might have the similar website. You can look at the solar production information. This is just for your information. Next slide, please. Installation. Once we size up a system, we need to get the job done. We go on the site, want to install the whole system. I don't want to talk about too much about the whole system installation, how to design layout, but I do want to give you a little bit more technical tips from the battery side. So the battery, all of our battery is already have the most easy installation way is M8 battery terminal. It's easy. You find the components in your truck most of the time. We recommend that use the M8 at the terminal ring, or if you don't go with the metric, then you go with the inches. So we recommend 5/16 inches of battery lock. That works perfect. For the knockout, we have the knockout with 3/4, 1 inches, and 1/4 inches knockout. It depends what conduit you want to use. So it's pre-made already. So it's just you can do that. And on the left side, I give a little bit of amperes reading on the battery. So you want to choose the correct wires based on the battery you picked. I propose you always look at the circuit breaker. So you want to size a little bit bigger than circuit breaker, so that will protect the conductor. So just let the circuit breaker break first, and before the wires start melting. Okay, next slide, please. Jeremy, I see the chat. Okay. Terminal ring and terminal bus bar selection. So we have the terminal bus bar in the market. You can always choose. Be careful with it. Just want to choose the right size. So M8 or 5/16 start. And when we make sure the voltage rating is fulfilled 48 volt. So some of the bus bar only 12 volt, but I already see that. So most of the bus bar has a good range of voltage. We recommend that you use the combiner if you have a bigger system. A lot of customers install 10, 15 system in the same solar system, 10, 15 battery in the same solar system. So you can use the bus bar. The bus bar the bus combiner. So we always use midnight a lot of times. It's go up to 1,000 amps. It's pretty easy for installation, save you a lot of time. But if you have a different situation, you can use the homemade bus bar tool. So that's available in the market. You just need to drill a few holes and then make sure you isolate it from metals and then the moistures. So that will work too. Next slide, please. Commissioning on the battery bank. So we'll talk about the two MOSFET based, and we'll talk about the EVO today. So On the LP5, LP10, the commission is pretty easy. So before we wire up the whole system, so we want to make sure all the circuit breakers are on the off position. But the most important thing is before you wire two battery bank in the parallel, you want to check the voltage, make sure they are less than 0.5 volt differences on the open circuit voltage. Right? Open circuit voltage means you put the circuit breaker on the on position and measure voltage to make sure they both at 0. They are all at 0.5 range. For example, one is 51, the other is 51.2. That's perfect. You don't want to see one is 51, the other is 53. And once you start a system, one battery is going to charge another battery, and then the lithium battery 2 volt means a lot. So there's a lot of capacity in 2 volt. It can damage the battery cell, can damage the BMS usually. We don't want to see that happen. Just make sure you check it before that. Once you wire up the system, then usually you turn on the battery's circuit breaker, and then you can start your inverter. Then the inverter will start once it has the 48 power come in. So that's how you finish the commissioning of the system. Then we look at the eVolt. Next slide, please. eVolt system is a little bit different because this one has embedded computer system, so we're able to control a little more on the inrush current. So we have the pre-charge circuit integrated, so a little bit different way to commission the system. We want to have you put the system on and turn on the inverter, and then we turn on the battery. So turn on the DC breaker doesn't mean you make the system live. We have to push the button in the front to start BMS, let BMS start working, then that means the battery is live. And we want you wire up the whole system, and then you put your circuit breaker on the on position, then turn on the inverter. Usually in these processes, the battery will jump to the pre-charge circuit and then charge up the capacitor in the inverter to make sure the inverter starts smooth, and then jump onto the main circuit. So whole processes take up to 30 seconds. So you will hear multiple click in the system, and then your system is commissioned. What if you have a 2 breaker or more breaker on the same inverter? For example, all the back. So the same processes. So a lot of inverter company has a multiple small inverter put in one enclosure, so they make one inverter. So we just need to use the pre-charge circuit for the first inverter. When we start second inverter, we don't need the pre-charge circuit because the surge power is relatively low. The system is able to handle it. So just follow the same process as the first step, and then turn on the second circuit breaker after 30 seconds or minutes, so that the LED system start smoothly. And the next slide, I'm going to discuss a little bit how to parallel the system. For the LP5 and 10, we allow the customer to parallel 2 battery banks in the system. We do recommend 2 ways to do it. You can do DC chain. If you do DC chain, make sure you put the power from both sides, positive from one side, negative from the other side. Just don't try to pull the power from one side. It's going to give it a lot of pressure on one battery and less pressure on the other battery. After 1,000 cycles, you will see the differences on the capacity deteriorating. Not good. So if you want to do DC chain, as I show on the picture on the left, so there's a B and C battery, then you want to make sure you pull the power from both sides. And the other way we recommend is we use the same length wiring system. Right? So if that's like eFlex or eVolt, we allow the customer to stack up 15 or 20, 40. Then we always want the battery has the same length of a battery cable and go on the bus bar and go to the inverter. It's easy for installation and also keep the balance charge and discharge of the battery system. As I mentioned, a couple of steps we want to follow. So make sure you check the battery voltage first. That's very important. No matter you do this or do lead acid, you always do that. And make sure all the equipment is off, nothing is on, all the equipment is off. We want to do battery product for wiring first. Follow the cabling processes. I mentioned two-way we recommend. DC chain for 2 batteries only. More than 2 battery, you go with the same length wiring system. And then do positive and negative separately, and then once you have it up, so where everything going to the positive and negative bus bar, and turn on all the batteries and commission your system. So the key takeaway here is check your voltage, follow the cabling processes and the instruction. Second, please. Next slide, please. Parallel the eVolt or eFlex system is a little bit more complex. It goes with 10 steps, but don't be afraid of it. So it's pretty straightforward. So we just want to build up a communication between each battery. So the battery embedded computer, the battery will talk to each other with CAN bus. So it helps you to monitor the voltage differences. If one battery has a problem, voltage drops so quick, or they have deteriorating differently and so on, the system is going to kick this battery out in the when you operate in the system. So the step we want to go with is you prepare your standard internet cable, and then we also want you to check the voltage, and then put oil breaker on the off position, and then set all your battery as a slave. So you see the LED is touch screen. So you touch M set, it will let you set as a master or slave. We want to use the set O in slave. And then we start wiring the battery cable positive and negative, as I mentioned in the last few steps. So then we connect the communication cable in between. And we want the reboot. We want the customer reboot all the system. So just turn the BMS off and turn the BMS on. Push the button in front of the batteries. And after you turn on the inverter, then you can change the first battery as master. What will happen is once the battery 1 become master, you start coordinate with all the other batteries to make sure the whole system are in the same voltage range, and then start supplying powers to the inverter. It's extremely useful when you commissioning a big system. You have 5, 10, that's the way you want to do it. You don't have to calculate everything with 0.5 volts and so on. And the system will help you to understand if this battery is in the range of a parallel system or not. We have detailed instruction in the user manual. You can go online at the www.thefortresspower.com resources. You can download the guideline and the installation manual that have a detailed instruction for these processes. Okay, next slide, please. Parameter setting. This is the last section of the seminar. Parameter setting. Before we understand the parameter setting, we want to talk about a little bit what is a typical charge processes and what is a charge curve, discharge curve on the lithium batteries. And we'll talk about it and try to let you understand as much as you can why we do this parameter settings. So 3 steps charger system works perfect for lithium phosphate. So the lithium phosphate don't need a floating charges, and the absorption time typically much shorter than the lead acid. The lead acid usually charge up to 60 or 70%, and then the other 30% need to be covered with absorption time. Lithium, we can do that too, but usually we don't recommend because lithium take more, we call it in the lead acid world, we call it the booster charger, right? Booster charger is just very normal for lithium battery. You can just use a booster charger charge to 85 to 95% already before you go into absorption time. And then we'll give a few minutes on the absorption time to get your battery up to 95 to 100% of full charge. So next slide, please. The charge and discharge curve, as mentioned, compared to the lead acid, the voltage drop from the whole process is very minimum. So we look at the 5-volt drop from the full charge to 80% of a depth of discharge. So the customer always asks, so can we tweak up a little bit on the discharge voltage and then charge voltage so that we can squeeze out a little bit more energy out of the battery? Don't do it. So the last 0.5 volt of the discharge doesn't give you too much, and the last 0.2 volt of charge curve doesn't give you too much energy. You try to keep your system healthy, just stay as the parameter we recommended. It's fully tested, we verify with multiple situations. It's no problem. If anything go out of it, it might go a little bit tricky when you do the system. Let's go next slide. So this is we also talk about the temperature impact. We always recommend you use the 77 Fahrenheit or 25 degree. That's the best scenario for the batteries. It's cool enough, but not warm enough, which is better for chemistry. And then as our instruction, it works all the way up to 43. And then if you have special temperature situation, we always recommend that you have a venting system. At least don't get the ambient temperature too high. You see the deteriorating of the capacity is significant because of voltage. Low temperature charged battery is strictly forbidden for lithium battery. So we don't charge under 0 degree or 32 Fahrenheit. So anything go over it, we have to consider the special situation. But if you have a normal room temperature from like 5 degree, 10 degree, all the way up to 40 degree, it shouldn't be a big concern. It's most of scenario we design into. So our enclosure already have good ventilation system. Most of the enclosure we use are the aluminum. Is a very thermal friendly system. So don't worry about too much. As long as you stay with our instruction range, you're good to go. Next slide, please. And we also talk about don't squeeze out too much energy from the battery. It will impact your life cycles. So this picture show you perfect. If you do depth of discharge 50%, it's gonna last super long. 80%, 6,000, right? Put you around about still at 75 to 80% of left capacity. If you do 100% at depth of discharge, so 2,000 cycle, probably you're already at 75%. This just give you some understanding why we don't want the customer just use the battery in the full discharge situation. Next slide, please. Okay, I don't want to go through the numbers, but you found most of the parameter in the inverter settings. If you go to the menu, you will see equalization, capacity limit, recharge voltage, bulk voltage, absorption voltage. Please follow the instruction. If you have a special situation, right, let us know. Then we'll look at your charge controller, and we'll look at your inverter to see if it's compatible with this or not. Most of the 48 volt system storage inverter will support three-phase charge processes, as I just mentioned in the first slide in the parameter settings. So I leave this to you so you can read it. It's very clear on the voltage setting. You might calculate a little bit the differences because you have too long of cable, there's a voltage drop. But other than that, this is a very good practice when you do the system setup. Okay, next. So here is an example of it. So how we size up and also do the parameter settings. So most important thing is don't forget to set up your parameter after installation. After installation, system working doesn't mean you can walk away. Check your parameter, make sure they are working, and walk away. If you don't check it, you have a good chance a few hours later, customer call you, right? Something wrong with it. So you want to look at the parameter setting. If it's correct, usually works, no problem. If it's not correct, after certain cycles, the BMS is going to interact with the inverter, stop giving powers or stop taking power from the inverters. So do parameter setting, very, very important. Next slide, please. Special case, special questions, send us email. So sales@fortresspower.com, or you can send also to the info@fortresspower.com. It's go to the sales or go to our technical support team either or. Let us know what we can help. We're here to help. We want to help the customer to size up the system. We want to help the customer to design the system. Let us know your special requirement. As I mentioned, we also do a customized solution. If you have a bigger system, 0.5 megawatt or 1 megawatt, let us know. We can help you on that. So I think that's pretty much the last slide. The last one, I will do a little bit of sales pitch. So installer benefit, so become our authorized installer. Very easy, fill out the application, join a couple of times a seminar, understand our product, and then we'll help you to design the system. So a lot of benefits, become an authorized installer. We'll push whatever the leads come to us in your region to you, and then we'll do co-marketing, and then you have a certain discount. Every time we do the promotion in the market, you are the person we always let you know, and then we also give you lock in the stock for you when you have a project pipeline. You tell us to do it, and technical support easy, and then of course we always invite you for our product seminars. All right, that's pretty much the presentation I want to give to you. A little bit over time, so.
We do have a couple of questions, so
yeah.
So let me see. Hold on one second. So the first question here is, what's the future of high voltage battery banks? We use up to 720 VDC battery banks for some of our projects, like microgrids that require medium to large scale storage and long run times. And greetings from Liberia. Hello.
Yes. Both low voltage and high voltage are great future. So low voltage, very easy to install and easy to play in the market with for the residential product. We do have the high voltage product in the pipeline. Maybe we should do a training for that too. It's usually 450 volt high voltage system. It's really determined by the inverter you choose. So if you choose inverter with high voltage, then we can make it compatible with a high voltage system. If the inverter is typically residential 48 volt system, then we have a low voltage, we call it 48 volt line. That's what I presented in this slide, just to support. Answer your question, both has a bright future. I see more voltage on the commercial grid or the large system, right? And the low voltage is more going to the residential and the special application. Low voltage for most of people is easy to play with, so less risk. High voltage, you need a certain license to handle it in certain area if you're an electrician. But I don't know if that's answer your question. So both are good. So as long as both are lithium battery, they're good.
Okay, we have a question from Patrick. In AC couple application, many customers like to oversize the PV array because modules are cheaper. Therefore, the PV inverter is often bigger than the battery-based inverter. Is this a problem when you're using Fortress batteries?
This is a problem for using Fortress battery. Not only Fortress battery. This is the problem for the storage part of your system. What I say is that the problem for the inverter and the problem for the battery, maybe. I think the battery has less problem. It's more problem for the inverter. So electric need to go somewhere. If you produce too much, you don't use that much in the house, and you want that the storage inverter take from the AC side too much power, something gonna happen. So what happened is the storage inverter will try to manipulate with their computer the frequency, and then tell the PV inverter, right, there's something on the grid. Pretend the storage inverter is the grid. So most of the PV inverter has a protocol with grid. Once they say grid is off, then they have to shut down to stop, to avoid supplying power back to the grid. Maybe somebody is fixing grid, they don't want the power go back to the grid. So that's the way they try to regulate the PV production. It works, but if you size way over too much, then this will happen all the time. Your customers say that in the house, and then very nice weather, they will see the light or some appliances on and off because of flashing. So try to give a customer best experience, and then size up your storage part of the PV inverter and also storage part of the storage inverter and battery slightly bigger to overcome this problem. Just a best practice, what I mentioned. I don't know if that answers your question, Patrick. You can keep typing if you have more questions. That's a very good question.
And one more question from Patrick, actually. In case of damage to the BMS, can it be replaced in the field?
Yes, it's a field serviceable, easy, front case off, replace BMS, and then it's good to go. We fully consider this potential problem because the battery cell is the most expensive part. We don't want you scrap the whole battery because of a piece of a PCB board. Yeah, it's field serviceable.
Okay, and Patrick just said that pertaining to Patrick's question, a lot of our AC or DC systems are off-grid in Africa.
Okay, that's perfect. So if it's an off-grid system, I give you a little bit the recommendation. If it's a customer want off-grid AC solution, it's better just let them do DC, just kick out the PV inverter. So usually, I don't know, I think the cost is pretty close, right? So most of the storage inverter can take the also have the PV. I think some of the transformer-less inverter even has the PV array port already integrated. So no matter you use or not, it's already there. Schneider out the back, you need a separate charge controller. So that's the only thing you need to consider. So if this off-grid DC couple is preferred, it's help the system coordinate better with one inverter instead of two.
I think that's all the questions we have for today.
Okay.
If anybody else has any questions, you can always email us at sales@fortresspower.com. And I will be sending everyone a copy of this presentation as well as the recording. So you will have both later on today. And if you have any questions, you can always email me. You will have my email. Oh, hold on, we have one question that just came through from David.
Yeah.
Do you have closed loop communication with some of the inverter manufacturers? Specifically, can the battery state charge be monitored through the inverter's online monitoring system?
Okay, so we on the eFlex and the eVolt, which has the smart BMS system, we both are working on the integration with Schneider and Autobac. So currently in test processes. As my understanding, the Schneider and Autobac, they are also working on that thing. So we're kind of working simultaneously to set up the communication. Schneider will go with their, they call it the gateway. So they have a separate gateway to do this function. If you want to build up, once we publish, we can communicate with the Schneider. You need to buy this gateway to be able to monitor and then do remote things. You can see the battery status as well. And the other thing is the communication usually give you a good visibility. If you look at the inverter online monitoring system, it will tell you, okay, what's the status on the battery as well.
Okay, I think that concludes our presentation.
All right.
Thank you everybody for joining, and stay safe, and we'll talk to you later.